In this video I want to continue the saga of this two-wire intercom system, which I already showed in an earlier video, how to hack and how to listen and speak onto the bus. The system works with only two wires, which are just connected everywhere in parallel, and the communication is going over it, the power supply and also the audio is going over it. So I had to install the system I had last time at our customers, so I managed to get some used telephone and outdoor unit to test further with, and I was able to reconstruct the power supply and made this schematic for it, and also created a PCB for it, which I already assembled, and I want to show this today and how the power management or the power system works on the system. This time it's a little bit more at the analog side and not at the software side and the communication side, just a quick show of how the system analog wise works, as it was really interesting for me to see how it all interacts, and it was a goal that was accomplishable for me. So yeah, I will show it now. So I have to say thank you to PCBWay. They offered me 5 PCBs for free as a gift. This video is not sponsored by them, they just were so kind and sent them to me. So I was curious about the quality, and so far it really looks good. So I assembled this PCB, and overall the PCB quality is very good. The botched wires are my own fault, and also the BD140 transistors are because of my own mistakes, because on the EasyEDA editor the pinout was not correct. It was returned by one pin, so everything was falling apart, but this way it still works. The power supply works with a few blocks I want to describe in different regions. For once we have this side here, which controls mainly the bus power output and is also controlled in the ampere rate, so it can be set to be at a maximum output of 360 milliampere, or if both resistors are enabled via this transistor, then it is at about 450 milliamperes. This BD140 transistor is as a power transistor in the schematic and regulates over these two resistors the power. Also, this resistor can enable, or this transistor can enable the power completely or disable it. We have here 5 pins to connect mainly the control lines. We have 2 pins here which are just 5 volt input, and also we have these 3 connections here. It's for once a ground connection, it is for once a 24 volt input, and the 24 volt bus output, which is then controlled via the power supply. Here on the right side we have the management for the audio, which will, if the output is enabled, pull the bus supply at about 22 volts and will enable the audio line go onto the bus. You can see this in my earlier video about it. Then we have for once this region and this region. This is for reading the bus via this resistors. It will turn or turn not on this transistor, which sits on the 24 volt line, and will then give out a 1 or a 0 depending on the data that is on the bus, as you also can see in my earlier video. This transistor here is controlled via the input line and can pull the bus power supply via a 7.5 volt Zener diode to ground. So this will just short the bus over the Zener diode to still leave some voltage on the bus, but also just pull it down so other devices can read what this power supply says on the bus. I now have connected everything like it would be in a real system, except for this power supply PCB, which we are trying to replace in this building. I have for once an internal telephone to communicate to the outside, and this is a module which gets behind the mailbox with a loudspeaker in here and a microphone. And on this one you have to connect some kind of button matrix, which can also just be normal buttons. I will bridge it just with this cable to emulate a push button on the outside. I of course have the current regulator PCB, I would call it. I have a 24 volt supply here with up to 1 ampere. I have this breadboard to just make it simpler to understand what I'm doing here. It's for once 5 volt from this power bank, which is in reality a headphone case. Okay, but that's not part of this video. We have here a ground line, we have a 5 volt rail, and we have here connected the bus device to ground, and the ground to this bus thing is also connected via the green cable. Then we have here the 24 volt rail of the bus system, which is already current regulated. And you can also see here on the PCB there are some LEDs which just say what status it is in. For once we have the output that is currently enabled. We have also that the 5 volt coming in from the control line to enable the output, and we have the different LEDs that I will show now. So we once can enable via pulling it high the next line, the enabled 2 times output. This way more current can flow over the bus, and I will set that back right now. Then we also have the next thing. This is enable mode 2 on my PCB, which enables the audio transmission, so these devices can better talk to one another. It will, as showed earlier, enable the audio circuit. The last one here is the speak to the bus line, I would call it. If I pull it high, the bus will pulled low via the Zener diode, and as you can see, the output LED goes darker, and that way the devices can talk to each other on the bus, as I showed in the other video. If I now push one button like this, the telephone will ring, and you also saw that there were some messages on the bus. So if I do it again, you can look at this LED, and there you saw it. This way the PCB or the power supply knows when somebody is talking. For example, if the door open button gets pressed, you can also see that the LED is lighting up. Normally it now waits for an acknowledge message from the power supply, but as no microcontroller is connected here, the power supply is very stupid. It's just, yeah, to explain it. Also the light button will send a bus message which will not get answered from the bus, so it will try it 2 times. I can now also speak on the bus, which is a very annoying sound, and I try to make it better for you. So like this, I can now talk onto the bus, and if I enable the bus output, the audio gets very much better. If I speak while pulling the mode low, it sounds okay-ish, but not so intense. And if I connect the audio mode, it will sound a lot better. I will try that again. Okay, that does not work while they are standing so close together. And yeah, I learned a lot, especially the analog part of this system is very interesting for me, and I just wanted to show it a little bit, that it's also possible to replace the power supply and make your own system out of it, or just use some information you gather via it to learn something, as I did. And I hope you liked it also. So that's it for today with this TCS intercom hacking continuous saga of this power supply. In the next video I may want to look inside the audio transmission. I already looked into it, and I also want to replace it and want to be able to listen via, for example, an audio input line in on the computer to the bus, and also to speak music, for example, from the computer to the bus. And yeah, stay tuned for that, and don't forget to subscribe. Have a nice day.